Hello and welcome to another video. Today I'm going to be going over some C programs that I learned in my Computer Science 1 course when I was in college. This first one is using dynamic memory allocation, and basically the structure behind the programs are that we have a C source file and a .in file for our input. In the repository I have included both the source file, an input and output.txt file, so you'll see an example of what they should look like, and an actual .in file that the C source file reads in. It'll write out a .out file. So basically what this program does is in the input file we have a bunch of different names, and each name has specific numbers. They're their lottery ticket numbers. So you can see in here we have 80 different people, first and last name, and there's the winning lottery ticket numbers for them. The output will look similar to this. We're going to give the program the winning lottery numbers, and it'll say these people matched with these many numbers and put them in a specific price tier. And let us know whoever won at least 3, 4, 5, or 6 matchings of the numbers. So let's look at the source file real quick. Basically what we're doing is we're using a struct. This is another function of the program, is to learn a little bit more about structs and typedef structs, as well as memory allocation. So we read in the input file, we scan in and allocate space for the lottery player struct. Then we scan in the data from the input file into those structs, ask the user for the winning lottery numbers, and then check those winning lottery numbers against each struct's numbers. And then we just print out at the end if a specific player struct had at least 4, or they're at least in the 4th tier, which is $10. Using this enum, this is how many numbers they matched of the 6 lottery numbers. Then we would give them a specific price tier. And the price tier is explained here in the PDF right here. So let's go ahead and run this program. So we'll compile it, and we'll run it. We'll enter the winning lottery numbers, and then go check the output right here. As you can see, this is the same that we got as our sample output file over here, which is basically just saying these people matched a specific number of the 6 lottery numbers, and they got put in a specific price tier. Good jobs to this person, they won a lot. Alright, now we'll continue on to the next program. Alright, so we're going to move on to the second program. This one is using linked lists, and basically we're running a shop. We have to use some predefined structs, and the whole business of this program is really using linked lists and dynamic memory allocation correctly. First, I'll show you what the source code looks like. Basically, we have 5 different commands we're looking for in the input file. Based on these commands, we'll do a specific thing. So we basically loop through the input file and look for specific commands. Those commands are being add item, customer, restock, inventory, and print day summary. When we add an item, we're basically taking an item with its name, its unit number, its price, its stock quantity and restock quantity, and adding it to our database of inventory. When we get the restock command, we're basically saying take this item and add the restock quantity back to the current stock quantity. A customer usually comes in and they will have a specific list of items that they're going to be buying, and on that list can be multiple item numbers with a specific number of that quantity. Inventory means that we're just going to be printing out the entire list of what we currently have in our inventory, and print day summary prints out the list of everything that we've sold so far. So I'll show you what that looks like. The input file. Adding lots of the items and their price and the inventory and their restock quantities into our stores database. And after we add all the items, eventually people will start coming in we'll check our inventory, we'll print what we've sold, which is nothing so far, and then we'll have 100 customers come in and they'll buy a bunch of different things. And they can be multiple customers on the same day. Maybe they forgot something, came back. And in between, we just keep printing what we've made so far. We'll check our inventory, restock it eventually if we need to, so people can come in and buy more of that same item. If they wanted to buy a specific item and that item was out of stock before we restock it, they would not be able to buy that item. So it makes sense. That would be a real case scenario. And basically at the end, what our output file should look like is a giant mess like this. These are adding the items to the database when we're adding them. This is an inventory right here when we're looking through what we have. So many units of each thing. Let me show you what it looks like when we get to the sales at the end. This is the print day summary. We'll have specific number of sales from a specific person purchasing so many items, and this is what they bought and how many and what their total was at the bottom. This person bought $4,000 worth of items. Pretty crazy. Bought a lot of whatever these things are. And at the end, we'll see our absolute grand total, which is about a little over $1 million, which is pretty good for a little store. So we're excited to do this. So let's go ahead and run the code. All right, we ran it, and we have this output file that was generated. As we can see, we did the same thing that our test output.txt file made. We have our items being added to the database, our inventory, and of course we have some shoppers as well buying some items. Sometimes it's hard to see because I'm scrolling through a really long, basically output file, which is just a text file. But eventually we'll get to the bottom. Hoping to see a little bit more of customers. There we go, we just passed some. Oh, here we go. Just wanted to give you an idea. This is what it would look like after we do an inventory. The inventory is always really, really long when we print that out. But here is a customer coming in, they made some purchases, we call a restock, and these are the items that have been restocked in a specific quantity. And then we have more customers come in, bought, and then we add some more items into, maybe we get new products in our inventory in the middle of the day because we heard that people like shopping for that item. And then eventually at the very end, you'll see we made a little bit over $1 million, which is pretty cool. So linked lists, memory allocation, and using more structs, basic C syntax, pretty interesting. And now we'll move on to the next program. Alright, so here's our third program, which is basically just all about recursion, learning recursion, using it with both the C programming language as well as data structures and algorithm analysis. We have a couple different commands that we can use from the input file, similar to our last one where we had inventory, customer, stuff like that. Our first one is called nights multiply, and basically this is just taking in two numbers, k and n, and multiplying the result from k up to n. So that was a simple intro to recursion program that we had to write. The second one is nights flip, which is basically just flipping a coin and seeing all the combinations you can have. So instead of heads and tails, we're going to print out nights or flips. So if we have drop it 4 times, we've got 16 different combinations that you can get out of that. We can get all heads, you can get all tails, you can get half and half, all in between. That was tedious. So the next one is nights shape, just given a number, that's the width that we have of this shape. The shape will always be an x composed of x's. Basically, this one's simple. You just write out a triangle that's increasing and decreasing in width. And once you get to the middle, you just reverse it back out. Night scotch is kind of like hopscotch, where you get a number line, and the number that you start on is how many you can go forward. From then on, you can either go forward or backward in that amount. And the point of this program is to see if it was solvable to get to the end. So in this one, you can see we could go up 4, we could go forward 2, back 3, up 5, back 2, and then forward 3 when we get to the end, so it's solvable. This is the PDF goes through the outline of how that can work. And say here's another one where you would just go forward 3, and then you could either go back 3 or nothing, because you can't go forward 3. So this one's not solvable because you just keep going in an infinite loop forward and backwards of 3. And the last one is Knight's Depot, where we are given a length of 2x4s from our team that they want us to buy in, say, feet, inches, whatever you want it to be. So 6 feet, 4 feet, 3 feet, 4 feet, 1 foot, and 3 feet. And say that the fixed length of the 2x4s at the store are 6 feet. So we try and find out the possible arrangement that we could buy to save how many we actually buy. So you can see we buy one for the 6-foot one, a second one for both of the 3s, a third one for the 4 and 1, but we have to buy a fourth one for the 4 that's left over because we can't fit these into one. So 4 is the minimum number that we need to purchase. So that's kind of what the input file looks like. Right here, these are the commands that we're going to be going through. Knights multiply with the numbers, knights flip, which is how many different ones. This is actually really long in the output file. You'll see 12 is 12 flips of a coin. Knight's shapes, the width of the X. Knight's scotch, this is our little hopscotch. And then Knight's Depot is what we need to buy for the 2x4s. You can go through the code on the repo, and it's really well commented, so if you need any help on the algorithms, let me know. But I encourage you to try it out on your own. It's a really great intro to recursion. So let's go ahead and compile this and run it. And we'll see in the output file. Let's open this up. So this is our output file that we just compiled. Here's the output file of the example. You can see that they're the same. Obviously this is multiplying 1 up to 9 yields 362,880. Yielding 2 to 9 gives the same result because the only difference is multiplying it by 1. So it would be the same. So that's what knight multiply is. Knight's flip can get pretty long. Here's knight's flip with 7, gets up to there with all the different combinations, and we print it out. Here's knight's flip with 12. I'm going to skip through this because that's line 151. We go all the way down to line 4,200. So you can see that's 12 flips of a coin, all the different combinations. It's crazy. Here's knight's shape, which is just going and printing it and then reversing it once we hit the middle. Knight's scotch, just the solvable and not solvable, and then how many 2x4s we'd have to buy at minimum to get those fixed lengths that we saw right here. And that's pretty much it for recursion. We'll go ahead and move on to the next program. Program, which is basically just going over stacks and queues in the C programming language. And we have a program that is a simulation of our registrar's office where we're having students actually physically come in and register for their classes. Unfortunately, even if they wait in line, they have to wait for a specific laptop to become available, where we only have 5 laptops available for the students. So we kind of simulate this using an outside line, which is a queue. A laptop waiting line is when you get to the front of the line, you're waiting on one of the 5 laptops to become available so you can register. That's a queue. We have a stack of laptops. And then we have a laptop return line where you must go and return the laptop. And then we have completed registrations, which we print out the students and what classes they registered for the day. So here's the input file right here. We have individual students and the classes that they want to register for. These students can actually have, this is the number of classes they have, and they can actually have a 1 or 0, which depends on if they make a mistake or not. If they make a mistake, they have to come back and re-register for their classes. Luckily, they don't have to go back in line, but they must, re-register for their classes before they return the laptops. And here's all the students for the day. I believe how the program works is that the students who are in line before the registrar closes are allowed to stay in line and finish the registration for the day. So if you're in line before 5 o'clock when the office closes, you can still get your classes registered for that day. You might wait and take until, say, 7 or 8 o'clock at night, but as long as you're there and you finish before midnight, they'll allow you to stay in line. So here's some of the code that we go through. Feel free to go through it on the GitHub. It's pretty well commented. So let's just go ahead and go through the code, compile it, and then just run it. Here's our output file. Oops. Let's not do that. Just did it twice. Third time's the charm, right? Here we go. For some reason, it doesn't like to remember that .out likes to be opened with a specific text editor. The .in is fine, though. It remembers. All right, so the day one, we have this student come in to the registrar, enter the laptop line, they check out a specific laptop, and eventually they will come and finish the registering, and they successfully registered so they can return it. Unfortunately, this person finished registering and entered the laptop return line, but they realized they made an error in the registration and they must redo it. So you can see this person comes back down here and finishes registering successfully and then returns it. It's assumed that after they finished the second time that they did not make any more errors. You can see this is a real-time minute-to-minute simulation of all the students that come in through the input file and how long it takes to do their specific actions. And it's detailed in the program description PDF how long it takes to do each thing. Like it takes 5 minutes to specifically register for classes. It takes exactly 1 minute talking to the person when you're returning your laptop, etc., etc. So in here at 5 o'clock the registrar would close, but they actually allow students to keep going until 7:01 on the first day. And then print out a day of 200 registrations with these students registering for these classes with that time code and these classes, etc. So that's basically how the program runs. And we'll go ahead and move on to the fifth and last one. So the fifth and final program in my Computer Science 1 course that we went over was binary search trees. Basically, we are writing a program that's making an ad hoc computer-computer network of wireless communication using binary search trees. So we have a list of students who are within range of a valid hotspot in the College of Engineering, and some other students who are outside of that range, but they would be within range if the student who is in range shares their wireless internet with these other students who are outside the range. So we have a different commands that we can send. We're basically going to be using the Euclidean distance formula in this. And the commands that we can do are join, find MAC, link, unlink, quit, show connections, print members, and move devices. So basically, these commands will be saying we have a new student joining the program. We can find the device based on its MAC address only if it's in the program. We can link two MAC addresses, which are basically just ints. They could be real MAC addresses, but for the sake of this program, they're just numbers. We'll link these two together, meaning that they are shared. We can unlink them. We can have someone quit the program, meaning they'll no longer show up in the find MAC. Show connections, which will show everyone who's linked to you. So if someone unlinks from you, this will not be showing up in your show connections. Print the members who are in the program, and move devices. This is if someone is connected and they move around, because we are going to find them on an XY coordinate, which is what the Euclidean distance formula is for in this. We're actually going to be finding them not based off of latitude, longitude, but just X and Y. Why not? Much easier that way. So basically, here we have some code that we're going to go through a little bit and show you. This is using lots of function prototypes that we have already made. And once again, the code is very well commented, so feel free to go through it on your own, try it out. Here's an input file where we have these commands coming through. We have some unlinks, show connections, move devices, and for the output you can see that we'll have error messages if something is not valid. Obviously we're trying to unlink computers that aren't even in the system. Also, they're not even linked together, so we have a triage of, we're going to say that they're not in the system first before they're not connected. So if they're already in the system, we won't print this message, we'll print, oh, they're not linked. So we go through this and we can see that eventually we'll start having people join the program and start linking their devices together. And you can see that as we go down a little bit more. Can't perform specific actions, but eventually we'll have these people join the program, and now these Macs are linked. We'll have these MAC addresses found when we use the find MAC command. Here's the members of the Nighthawk internet share already, and their X and Y coordinates, so where they're currently at. Eventually, let's see if we can find some show connections. Connections to this MAC address is this person currently at this position, total of 1 links and 1 active link. And this is how far away they are, specifically in a distance-wise to this person's MAC address. So you can go through it, feel free, ask me any questions, and that's the end of the Computer Science 1 programs that we went with. It was mostly just data structures and algorithm analysis written in the C programming language. Thanks, hope you enjoyed it.